Okay, Assalamualaikum, good morning. Dengar ke? Boleh dengar suara I tak?
Dengar
Okay, okay, so we have 23 students. So if I look at attendance, lebih kurang lah. Okay, so apa khabar semua? Sihat semua? Okay ke semua? Suara I clear tak? Christian, how are you? Okay. Sihat good. Alright, so you dah cuti seminggu Okay, good. Thank you, Khairul Afiq. So my voice is clear. So I hope everybody can hear my voice. Okay. So macam mana cuti? Macam mana sambut raya? Okay? Okay tak?
Okay.
Okay lah kan. So this is our first class after we have a break. Minggu kan break. Okay, start from this week. So before this we have first test. Okay, and then so starting from this week, we're going to start new topic on fault analysis. Second chapter. So I ada share dekat group WhatsApp. So you all dah open ke? Kalau you sempat, you can see from my slide here. Kat sini I can will share my screen later, right? Okay. Right. Present now. Okay, I share entire screen. Okay. Okay. So, boleh nampak ke screen? Boleh. Okay, good. Alright. So chapter 2, fault analysis. Okay. Basically, fault analysis is the I can say continuation from chapter 1. You tahu from chapter 1 we study about power transmission component. So dalam power transmission component, it has a lot of transformers. So transformer, you tahu lah, it has a secondary and primary winding. In order to analyze the system network, so we have to do the kat sini about per unit system. Ini ada refer tadi we need to do per unit system based system because we are using different voltage level because of the existence of transformers. Alright. Okay, however, in the fault analysis is not only per unit, of course. We study the fault. You tahu semua fault apa? Fault. I think semua faham pasal fault. Ground to ground. Sorry, single phase to ground, three phase fault, single phase fault. Itu fault. This some kind of disturbance in the network, in the power system network, where it can cause the failure ataupun in term of power supply from generation to load. So okay, so look into the fault chapter 2. Okay, but before we study about the fault analysis, right, we look into the per unit. So what is per unit system? As I mentioned earlier, per unit system, because in the transmission network, okay, there are a lot of transformers. Bila you transformers, there are different level of voltage. From generation, transmission, and distribution. These are different level of voltage. Because there are different level of voltages, we need to make one standard atau kata one system that we need to convert to the per unit system. Okay, in the power system analysis fields of electrical engineering, per unit system is the expression of system quantities as fraction of a defined base unit quantity. I think you all semua tahu pasal per unit system. You dah belajar kan sebelum ni? Pernah belajar tak? You ada basic kan?
Ada, sir.
You dah tahu lah ni. Ini cuma mungkin nak recall balik lah. I think I tak perlu go detail because I think you dah belajar mungkin dalam diploma level maybe ataupun you dah masuk kelas sebelum ni. Okay, so basic equation for point system, this one quantity in per unit, actual quantity divide by the base value of quantity. Okay, so these are the general equation for power, apparent power, S, voltage per unit, S per unit, I per unit. Semua it must be divided by the base. Kalau voltage need to divide by base voltage. Okay. Independent system or circuit choice are valid. So this is right. Sama lah, yeah. Okay, I skip this one. Whereas the base impedance is found as, okay, then you need to determine the base impedance. Semua equation ni you need to memorize lah, you kena ingat lah. And the base current given as the formula. Okay, tak apa. Mungkin mungkin you ada ingat tak ingat lah. Kita tengok lah one by one slide ni. Sometimes the equipment such as generator, transformer and motor have their own per unit impedance, ZPU. New base voltage. This means that the old per unit impedance or reactance have to be converted in accordance with the new base using the following equation. So this is the impedance, conversion of base. Semua ni pun you tahulah, ya. Okay, tak apa. Okay, kat sini dia mention as rated ataupun sometimes kita boleh katakan this is the old base and new base in the equation kat sini lah. Okay. Right, ni pun sama. Sama nak masukkan punya. Okay, wait. Okay, right. Okay, advantage of a system, it gives us clear idea of relative magnitude of various quantities such as voltage, current, power, impedance. Right, the per unit impedance of equipment, generator and transformer fall in a narrow range regardless of equipment rating, whereas the impedance in ohms vary greatly with the rating. The per units of impedance, voltage and current of a transformer are the same regardless of whether they are referred to primary or secondary. The per unit system are ideal for computerized analysis and simulation of complex power system. And the last one is the circuit law are valid in per unit system, and the voltage and power and voltage equation are simplified since the factor of 3 sets are eliminated. Okay. I think boleh baca lah benda ni sama je. Ceritanya you have to know the equation kat sini how to convert from the normal setting to the base. Okay, boleh baca lah kat sini. Right. The assumption made in symmetrical fault analysis. Okay, tak apa, this one sikit juga sebab agak panjang nak baca. You nanti go through by yourself dalam nota ni. Okay, per unit equivalent circuits, loads, transformers, transmission lines. So you kena betul sketch or draw the per unit equivalent circuit for the after you convert to the per unit system. Load, transformer, transmission line basically kita akan represent as this diagram, gambar macam ni. Motor, dia mesti ada R and L. Okay, generator. Okay. Okay, sebab kita tengok pada mungkin look at the first question how we convert into per unit system. Example number 1, tengoklah. Okay, untuk ingat balik apa yang you dah pernah buat sebelum ni. A power system consists of generator because per unit system ni very important. Kalau you nak buat fault analysis, right, you need to understand how to convert the system into per unit system. So starting from PU system lah. Later kita akan buat fault analysis. Okay, so you kena faham betul-betul lah macam mana nak buat benda ni ya. Okay, a power system consists of generator, two transformers, a transmission line and motor is shown below. Okay, so let's say this is the power system network. We have so di kat sini lah generation, generation or generator lah, generation level. So dia akan transmit power to the load. Okay, so in between there are two transformers, T1 and T2, and this is the line, transmission line N1. Okay, the rating given as below lah macam ni. Yeah, for generator, transformers, line, impedance, transformers, rating, okay, and etc. Alright. Okay. Okay. So what we need to do, the first step is, kalau if you look at the notes here, soalan ni lah. Okay, this question, you need to divide the system into different zone voltage created by each transformer. Right. So cerita kat sini, for this question, because we have two type of transformers, numbers on there two, first one is this one. Ini kita the step up transformers, the second one is the step down transformer. You have to divide the zone, kita kata zone based on the transformer winding. Okay, for let's say in this solutions, so they divide the middle of T1 and T2. Okay, so for the primary side, we consider as zone 1. Secondary side and primary side for T1 and T2 is zone 2. And secondary side for T2 zone 3. So you have zone, zone 1, zone 2, zone 3. So we divided the zone according to the transformer betul winding, secondary, primary and secondary. Itu the first one. Okay. Okay, soalan ni kata by taking the MVA rated voltage of generator G1, yang ini. Okay, number one, convert all impedance according to the MVA base, new base MVA and base voltage. You tengok kat sini, dia punya tak sama lah. Kat sini, base dia tak sama. So we have to refer to the G1 base, which is 100 MVA and 12 kV. Okay, so the first step, find the zone based on the transformer connection, primary and secondary. Okay, all right. So now, next, what you need to do, you need to find the base 1, base 2, base 3, VB1, VB2, and VB3. So this is VB1, VB2, VB3, based on the zone. Zone yang you marking tadi lah. Right? Okay. So, equation, because VB1, we are referring to the generator 1. Generator 1, V ni voltage lah. Voltage VB1. So, generator 1 is 12 kV. So, VB1 automatically become 12 kV. So, how about VB2 and how about VB3? Okay. For formula to determine the VB2, inilah dia. VB1, like for example, VB2 equivalent to VB1 times VHV, VLV for the transformer 1. Okay, look, which one? This is transformer 1. So this is the HV and this is the low V, LV, low voltage, high voltage side. Okay, question there. HV, LV. So because VB1 is 12 kV, right? So transformer 1, high voltage side is 120, lower voltage side is 11 kV, right? Referring to this rating. Okay, 120 is the high voltage side. This is low voltage side. Now we are determining VB2. So we just referring to this formula. So you substitute into this equation. VB1 is 12 kV times 120 by 11 for transformer 1. So you will have VB2 is 130.91 kV. So voltage for VB2 is this value, 130.91 kV. Okay, similarly for VB3, where is VB3? VB3 is this side. So dia akan refer kepada this VB2. Right? So look at the solution here. VB2. So transformer 2, transformer 2. Okay. Right, this one. Right. So you have here is VB2 is from this value 130.91. Rating for transformer 2 low voltage side is 11 kV. This is 11 kV divided by the 130. So there you can obtain a value of VB3 of 11.077 kV. Now we have all the value for VB1, VB2 and VB3. Okay, straightforward. You can tahu formula ni lah. Okay. Alright. You nak buat apa? Basically you want to draw the per unit equivalent circuit. So you need to know all the per unit impedance for each elements. For example, this is the generator. This is transformer 1, line 1, T1, T2, sorry. And load, So the first step, you need to determine the base voltage by using this formula. So now we have all the VB1, VB2 and VB3. Faham sampai sini? Faham Boleh Ya, I cuma
Faham.
cakap benda yang
Faham, sir.
okay, you dah tahu kan. Tapi tak apa. Okay. Dah ingat balik. Okay. Next step, inilah dia. You need to determine all the per unit impedance for each element. Right. So formula ni, ya tadi I refer to this formula. Yang ni lah, nama lah. Okay. This is a very important formula in per unit system. Okay. Right. Look at this slide dulu. Okay. Kita buat one by one. Okay. Impedance for generator. ZGO S base SG divided by SG times VG square divided by VB1. So for the old one is from the questions. Question idea. This is the old ZG. Okay. Okay. So the old ZG is 0.1 plus J 0.9. Okay, someone enter my room sekejap. Okay, I hope jangan kalau you disconnected is okay tapi jangan lambat join class because you macam ni lah kan, you akan disturb orang lain sebab saya tengah mengajar, you baru masuk tapi kalau you disconnected, I tak cakap apalah. Okay, alright. Okay, kita selesai kat sini alright, here. Alright, so we have ZG, this value. Base SB is 100 because we referring to the G1. G1 is the SB SSG sama VG VB1. VB1 is 12 generated voltage 12. So you have the Z per unit for generator is 0.1 plus J 0.9 per unit. Okay, for T1 pun sama, but now we have to substitute this formula for ZT1. Sama lah, ZT1 refer to the question kat sini. Transformer 1 is 0.01 plus J 0.005. Okay, this one Okay, S base is 100 MVA. Where does it come from? Inilah dia. Because we refer to G1 Okay. So 100 MVA divide by S transformer 1 rating S transformer is 50 MVA. Okay, 50 MVA. And then V transformer 1 11 divide by base 1 base 1 tadi yang kita kira tadi lah. This one right. V base 2 base 3. So just substitute into the formulas. There you have T1 per unit impedance. Okay. Similarly for T2 and motor, benda yang sama cuma you have to be careful on this base. Jangan salah base Kalau T2 B2 M B3. Kenapa you pakai ni? Because this element transformers is connected at the base B2. Ini pula dekat B3. That's why dia It's using the B2 and B3 for this T2 and M. Okay. Right. Okay, now we have all the impedance per unit for G, T1, T2, and M. Okay, the last one you need to determine is this one, line impedance in per unit untuk ohms. Ceritanya you kena macam biasalah, you kena convert to the per unit Z based system. Okay, for this case, you have to first determine this one, Z base 2. Because the line in between the base 2. So we B2, we base 2. This is the value of we base 2, 130.91 kV square divided by the 100 MVA base MVA. And then you dapat ZB2 is 171.374. Okay. So in order to determine the per unit system, okay, for the line, actual divide the baseline. Actual is 12 plus J75. We can obtain from these questions. 12 plus J25, 75, sorry. Okay, divide by the Z base. Then you can get them for Z line. Okay. All right. Now we have all the system for all the components in this network. So the last thing you need to do is you have to draw the per unit equivalent circuit. Macam ni lah dia. Dalam soalan you kena draw macam ni lah. Okay. So boleh faham ni? Sampai sini boleh faham? Okay kan? Semua simple je.
Okay.
Straightforward. Okay, look at the question example number 2. Ada circuit example kat sini. Okay, mungkin circuit ni dia macam complicated sikit. Tapi dia idea dia sama saja. Dia tak ada beza. Okay, tak apa. Kita tengok pada question example number 2. The one line diagram of three-phase power system is shown in figure 3.9. This is referring to the this figure dalam buku teks. Di sadat lah ni. Select a common base of 100 MVA and 22 kV. So it's given MVA 100. It's not referring to G, but this is the base from the question. Draw on the draw an impedance diagram with all impedance include the load impedance marked in per unit. The measure data given. So this is the data for the elements. Semua ni lah. Right. Okay. Right. Okay. The three-phase load at bus 4 load. Okay, where's the load? This is the load. This load. Okay. Absorb 57 MVA, 0.6 power factor lagging at 10.45 kV. Line 1 and line 2 have reactance of 48.4 and 65.43 respectively. Okay. So, cerita yang sama, you have to determine the per unit system for this network. So, start from sini lah. So, ceritanya you have to divide by the zone. By referring to the transformer connection, primary and secondary. Alright. So, look at the solution kat sini. So, first dia akan divide kepada zone 1, zone 2 and kat sini ada zone lah, dia kira zone 3 because dia ada start yang bawah ni. Because kita refer pada sebenarnya zone 2 dengan zone 3 sama. Tapi ceritanya because we have 4 transformers, that's why dia akan ada 4 zone. Zone 1, I refer to this side, zone 2, zone 3 and zone 4. Okay. Zone cerita macam tadi lah, because dia ada different voltage level, referring to the primary and secondary transformers connection. Okay. Zone 1, zone 2, zone 3 and zone 4. Okay, for this one, macam tadi lah, change of base. Yang sama. Okay. Contohnya kita tengok pada first one, XG, SGO, SB divide by SG time VG square, VG over VB1 square. Okay. So SGO is what? Dalam soalan ni is given as 80%. So dapat 0.18. you have 0.18 this side. As base given in the question 100, SG base for apparent power for generator is 90 MVA. Okay, this is the generator voltage 22, base B1, question 22 from the question. So substitute into the question, dapat the value of generator per unit is 0.20 per unit. Okay, transformer 1 sama juga. Right. Tapi macam mana you dapat ni? You dapat base ni for the base for B1 you kena kira lah. Calculation dia sama juga dalam macam ni lah, you kena kira base base yang ini. This is the how we determine the base. Sebab in this solution dia tak tunjuk cara dia dapatkan base. Kalau transformer 1 senang base 1 ni automatically refer to the this one because generator level voltage ni sama dengan dalam soalan dia kan, dia pakai 22. Base 1 should be no problem, but when it's come to base right, base 2 you kena kira lah. And base 2 pakai formula ni yang ni Okay, sama saja. So kalau you kira macam ni, you can for base 1, base 2, so base 2, base 3 and base 4 for this question, you akan dapat nilai ni lah. You boleh cuba buat lah ni WB2 is 220, WB3 is 110, WB4 is 11 kV. So if you have all the base voltage, then barulah you dapat kira untuk per unit impedance for each element, generator T1, T2, T3, T4 and motor. Okay, right? So ceritanya you need to know, you need to use the correct base voltage. I rasa tak susah pun kalau you nak tukar to the base voltage, because you just follow this formula. You akan dapat dalam base tu. Buatlah nanti later on you buat masa you buat study you kena buatlah, dan you kena dapatkan nilai yang sama. Ini tak salah, yang betul. Okay, the next one is you need to determine the line macam case macam tadi juga. Cari dulu base untuk line 1 and base untuk line 3. Okay, so this is the formula, right? The key here is the base voltage for B2 and B3. So for ZB2 is 484, ZB3 is 121 ohms. So from here we can determine the per unit for the line 1 and line 2. Okay, then later barulah you kira untuk okay, dekat sini kita ada load dia soalan ni dia ada load so load pun you kena tukar convert to the per unit system. 3 phase load ini okay, this is the load. So in this case solution dia bagi you have to know the base 4 right, divide by the 10.4 ni apa, actually it's come from the voltage kat sini. Load voltage is 10.45. Okay, so now you have 10.545 divide by the base 4 11 kV, you dapat nilai 0.9 per unit system. Okay, so to determine the S load, ini daripada soalan 57, S base cos power factor, ini power factor from the question 0.6, so you have the S load in per unit. Everything must be changed to the per unit and then barulah you kira the Z. Okay, kenapa Z? Sebab semua kat sini ialah Z semua ialah Z. Impedance. This is impedance. Sebab kenapa you nak kira impedance for all element, because dalam fault analysis you kena tahu impedance for each element in the network, barulah you tahu berapa fault current tu berapa. Sebab equation V equivalent to IR kan, so I fault equivalent to V over R, so you have to know the R, the resistance ataupun kita kata impedance lah kat sini. That's why dalam case equivalent circuit ni you kena tahu dia punya impedance value for each element. For generator, transformers, line, transformer 2 refer kat ini loads, this is the load. Barulah you boleh kira, oh this is the value for the fault current barulah kita tahu. Bila kita tahu fault current, apa kita buat, kita boleh tahu the size of protection device nak guna lah, berapa besar relay protective relay yang kita nak guna. Because we need to know the size of the value of fault current by referring to the impedance kat sini. Okay. Alright, sampai sini saya rasa semua boleh buat lah insyaAllah sebab you dah belajar. Mungkin kalau you lupa pun, kalau you buat sekali you boleh ingat simple benda ni. Okay. Okay, kita tengok pada this our main focus on the fault Ini sebenarnya ini untuk you faham kalau you nak buat fault analysis, you need to understand the per unit system. You kena faham betul-betul lah baru you pergi pada fault analysis. Okay, cakap balik Okay, symmetrical fault. Okay, part 2. Alright. Fault can be defined as any failure that interferes with the normal flow of current to the loads. Semua orang tahu tentang fault. Boleh tak sebut pada I, what kind of fault yang you tahu in the power system network? Apa yang fault? Apa yang faham pasal fault? Siapa boleh cerita sikit? Fault ni apa? Okay. Ini apa benda ni? Siapa boleh tahu? Apa yang you faham pasal fault? Fault fault in power system. So cerita sekarang ni lah dia ini antara fault dia ada short. Kita tahu transmission line dia transmit power in three phase system. Senang cerita transmission is three phase. Kan, betul tak?
Betul.
Dia ada, kalau you tengok transmission line kat luar tu kan, power apa kita kata power transmission power transmission line lah kita katakan tengok apa ada kat sini. Okay. Right. Overhead line lah macam ni kan. Biasanya dia akan ada 4 wire yang ini yang kita kat luar sana ada 4 wire ni. Ini transmission lah ni ada 4 wire biasanya. Okay. Kenapa ada 4 wire? Dia ada ialah ni kalau ikutkan kat sini RYB 3 phase So kat bawah ni ada ground. Jadi fault ni kalau anything that shorted all the line ni mungkin tiga-tiga wire akan short together. Right? Ini kita panggil symmetrical fault fault yang tiga-tiga ni connected.
Tapi yang merah tu macam tak connected
tak, ini lain. Ini saya ikut contoh Okay, inilah single line to ground. Maksudnya satu line tu dia connected dengan ground, single line. Ada line to line fault. Ini between line dia shorted. Kalau cakap tadi kalau tiga-tiga shorted tu three phase fault dia symmetrical fault. Yang kita nak belajar kat sini ialah kita nak fokus dulu pada three phase fault ataupun symmetrical fault kat sini kan. Maksudnya tiga-tiga line tu dia shorted together. Yang you nampak di dalam gambar ni mana dia? Ini lain, ini fault. Ini kita kata unsymmetrical fault. Mana kemudian mungkin because in a real practical tak semestinya dia akan tiga-tiga shorted. Sometimes dia between RYB ni, line ABC ni mungkin kalau case ni ialah shorted. Ini kita panggil dia short ni patut pada ground pula ataupun line to line fault ada shorted between the line. Ini kita panggil single line to ground, ada sambung pada ground. So this is the type of fault in power. Okay, senang sekarang you boleh tengoklah apa masalah dia fault ni. Fault ni masalah dia biasalah dia boleh distort the kata dia boleh disturb the power system supply. Dia boleh ada crash over, dia akan meletup ke, dia akan ada spike. Kita tengok pada the size of fault tu sendiri. Sometimes dia boleh explode, dia boleh terbakar, dia boleh dekat di sini, nampak kan? Very dangerous sebenarnya. Kat sini pun clear ada type of fault boleh nampak kat sini. Okay. 3-phase fault, tiga-tiga shorted. Line to ground, line pada ground. Double line to ground, line to line, between the line. Kat sini dia cuba tunjuk kat you lah. 3-phase fault. Okay. Ini line sambung pada ground. Line to line fault. Double line to ground fault. Banyak jenis fault. Of course, setiap ni dia akan create different impedance. That's why you kena kira per unit system. Different impedance. Dari situ you akan tahu berapa fault current. From the fault current tu, the size of fault current, later barulah you boleh decide the size of relay you nak pakai. Berapa besar relay? Protection relay. Protection device yang you nak guna untuk protect you punya network. Okay? Right. Okay, kat sini ni pakai macam-macam lah kalau you minat tengok. Alright. Okay. So, you go to this one. Alright. So you tahu pasal fault bila you imagine fault, I nak you imagine there's four lines, transmission line, RYB, ABC, dan satu lagi ground. So maybe the three RYB tu dia shorted sekali. Itu kita consider as a three-phase fault. Mungkin ada between the line, line to line fault, ataupun line tu dia shorted dengan ground, line to ground fault. Itu jenis type of fault. Okay. So fault can be defined as any failure that interferes with the normal flow of current to the loads. They can occur in power system when equipment insulation fails due to insulation fails. Insulation ni kalau kabel, you tahu kabel kan? Transmission kabel tu sometimes ada problem, issues, dia fails. Kenapa dia fails? Due to what? System over voltage due to lightning or switching surge. Mungkin ada lightning strike, ada kilat dia boleh menyebabkan akan berlakunya fault boleh. Mungkin kita punya kabel tu nanti dia akan terbakar dia terbakar, dalam tu ada copper, dia akan jadi short circuit. Kita tahu kabel ni basically dia akan ada protection juga kalau you tengok kabel Okay, ni email apa benda ni. Okay. Alright. Okay, kita tengok pada kabel, power kabel power kabel. Bukan senang kabel you nak kata nak fail power kabel. Tapi because of the lightning, saya tahulah kan kalau lightning strike tu voltage dia sangat tinggi dia boleh menyebab power kabel no. Yeah. Kabel kata contohlah SLPE kabel SLPE kabel ini biasa digunakan dekat apa yang keluar ni terus pakai bling XLPE kabel. Okey, ini kabel-kabel yang digunakan kita tadi lah contoh RYB ground Bukan senang kabel macam ni dia nak orang kata fail in term of operation. Tapi because of the lightning strike contohnya, over voltage, dia boleh terbakar dan dia boleh akan open to dia punya copper tu yang which carry current tu the environment, so that's very dangerous dia boleh short dengan dia ada phase okay, insulation, contamination, mechanical and natural stress, whatever is mechanical stress, mungkin sometimes orang buat construction dia terkena kabel tu boleh putus ataupun dia boleh lah damage, so dia boleh menyebabkan fault Okay, in most fault a current path form between two or more phases, one or more phase and the neutral. This current path has low impedance represented by Z fault, resulting in excessive current flow. So during fault apa jadi? It has a low impedance. Kita balik pada Ohm's law, VIR, I equivalent to V over R. Kalau you ada load R, current you tinggi lah, betul. Itu sebab tu bila berlaku short circuit, you punya apa kita kata resistance jadi rendah because dia short circuit. That's why current tu lagi tinggi. Current fault tu tinggi. It's not like the normal current. Kalau rumah you mungkin 30 ampere lah kan, you tengok kat breaker you. Fault current it can be 10 time 50 time higher than the normal current, rated current. Sometimes tengok pada voltage level juga. Kalau voltage lebih tinggi, lagi tinggilah fault current you. Alright. In electrical power system, a fault is any abnormal flow of electric current to the load due to the failure or breakdown in power system. For example, a short circuit is a fault in which current bypass the normal. Ini maksudnya when we have short circuit, current bypass the normal load. Make the that's why dia punya betul kita kata low resistance, low impedance during the fault because current tu dia bypass the load. Current akan increase excessively. Okay, in the three-phase system, a fault may involve one or more phases and ground, or may occur only between phases. If a fault occur between phase and ground, such as between conductor of transmission line and tower structures, it's called a flashover. Flashover. So you kat sini boleh tengoklah. Kita tengok example of flashover. Okay. Flash over. Kadang-kadang you kena tengok picture baru you imagine flash over. Ini benda ni keluar lain pula dia. Okay, atau kita kata fault lah kat sini. Saya main tulis sini. Fault. Line fault in transmission tak flash kartun dia salah eja pula. It's okay, tapi ceritanya dia akan use spike yang tadi pun ada spike tadi kan. Cuba sekali lagi flash spike voltage lah, senang kita spesifik lah voltage spike. Pun tak ada juga it doesn't matter lah, tak apalah. Okay. Mungkin kita kena pakai Google lah. Kalau pakai kata engine lain tu dia tak apa tu accurate macam Google tak apa Okay. When a fault occurs, the high current flow in the line are detected by the protective device such as circuit breaker. Kenapa? Memanglah kalau ada fault, you kena clear the fault. Circuit breaker mesti turn on untuk clear the fault. Kalau tak clear apa jadi? Semua equipment akan damage. Circuit breakers are affected, transmission line will be automatically open, isolating dia akan isolate, dia akan cut yang mana fault area until the fault can be located and cleared by repair crew. Jadi kalau you fault happen macam kita tadi lah, it will damage the system. The important we need to know the fault currents. Berapa the capacity of fault current in order to determine the circuit breaker rating. Okay. Kalau tak tahu kenapa, tak boleh lah. Kalau you let's say fault current you mungkin 1 kilo amps tapi you punya setting transformer setting untuk protection device relay you letak rendah sangat ataupun tinggi sangat pun dia tak efektif. Okay, it must be effective in the setting for the protection relay, protection device. Okay, categories of fault can be categorized in two ways in terms of how long the fault happens, transmission fault and permanent fault. How the fault happens? Okay, dia ada dua kat sini. Symmetrical and unsymmetrical fault. Ini yang sebut tadi, I tunjukkan picture untuk you. Okay. Okay. So for the symmetrical fault, three-phase fault. Kenapa dia symmetrical? Sebab fault current for the each phases dia sama Same for each phase. Dia sama. Phase A, phase B, phase C. Sama saja. Itu panggil symmetrical fault. Dia three phases shorted together. Tiga-tiga tu dia short circuit. Yeah. However, for the unsymmetrical, kita divided into three groups. Single line to ground, SLG. Single line to ground. Satu daripada tiga tu, one line is shorted to the... Mana gambar tadi? Ada kita gambar tadi? Tak ada. No, kita kena tengok sini lah bagi you clear. Fault Kita pakai Google jugalah kan. Kalau pakai yang jelas Google Google jugalah. Ini contoh tu dapat. Ini macam ini contoh flashover Okey. Ini ada bahaya flashover dia boleh sistem itu memang lebih terbakar lah dekat area tu Okey. Kat sini pun flashover okey, kat sini pun ada. Mana lagi three phase fault Okey, ini pun tunjuklah. Tunjuk kat dia line to line ground fault. Ini pun ada kat sini. Okay. Dia connect kepada ground. Ini line to line fault. Itu contoh dia. Okay, tak apa. So single line to ground fault, line to line fault, double line to line. Kalau double line ni dua line lah, shorted and dia join dengan ground dia short dengan ground. Apa jadi? Current tinggi because current you tu masa fault tu dia akan bypass the load. Dia akan straight forward to the ground So current sangat tinggi masa tu. Short circuit current Okay. Category of fault, symmetrical fault, three-phase fault, balance fault. The magnitude of AC current in each phase are the same because they are symmetrical. Sama All three phases of transmission lines are shorted together. The more severe fault but happens infrequently. Yang biasa berlaku yang ini yang bawah ni unsymmetrical fault or unbalanced faults. The magnitude of AC current in each phase differ. Dia tak sama sebab dia dipanggil unsymmetrical. Phase A, phase B, phase C, current short circuit current tu, current fault current dia differ, dia tak sama Can be subdivided into three. Sekali lagi lah. Single line to ground fault, one line touch the ground. Satu line sama pada ground. Line to line fault, two lines shorted Maksudnya line A, B, C, mungkin A dengan B dia shorted. Double line to ground, ada dua A, B short, dia pergi pada ground. Touch dengan ground. Okay. Ini happen kalau you punya isolation tadi dia fail lah. Mungkin for any reason lah dia boleh damage the isolation menyebabkan dia shorted dengan ground. Okay. Sini pun ada three phase fault, balance fault, symmetrical fault, unsymmetrical fault Alright.
Sir.
Yeah.
Yang kalau dia line dengan line, kalau tiga line sambung sekali tapi dia tak connect ke ground, so yang tu unsymmetrical ke symmetrical?
Kalau tiga-tiga dia kira symmetrical fault. Dia sama.
Even dia tak connect dekat ground?
Ya, tak apa. Dia as long dia short je tiga-tiga.
Okay.
Yang ini dia tak pada ground tak apalah sebab phases current tu sama untuk tiga-tiga line. Dia sama sebab nanti current fault dia akan pergi ke ground juga nanti.
Okay.
Walaupun sometimes dalam dia tak tunjuk lah kan ground, tapi kita faham kalau tiga-tiga shorted consider as symmetrical fault. Kalau yang macam ni dia tak sama because current ni lain ni. Kenapa lain? Because impedance dia tak sama Ini impedance sama ni, impedance dia kan. Sebab dia bersambung. Sebab tu dalam balance unbalance current or voltage dia tengok pada impedance. Kalau macam ni impedance dah tak sama dah. Jadi dia jadi unsymmetrical fault. Ini pun tak sama kan. Impedance dia berbeza. Kenapa berbeza? Sebab dia tak sama dah, lain dah. Current flow dia tak sama dah. Ini sama ni, dia shorted Alright. Setengah dalam ni dia tak tunjuk ground tapi kita tahu kalau dia shorted tiga-tiga tu kita kira symmetrical fault. Okay. Causes of fault. The cause of fault are momentary tree contacts. Tree contact tadi. Bird or others animal contacts. Mungkin ada burung ke, whatever. Dia bergayut, mungkin animal, monyet ke bergayut dekat tu. Tiba-tiba dia shot. Mungkin tangan dia pegang dekat face A, kaki dia dekat face B. Dia akan shot kan. Matilah dia. Biasanya monyet lah kan. Burung pun sama. Lightning strike, conductor clashing. Alright. Conductor clashing dalam kabel tu ada conductor, dia clash. It's something, dia berlaku benda semua. It's normal happen. Weather condition, heavy rain, heavy winds, snow, ice, whatever is weather condition. Equipment failure, ionization of surrounding air due to smoke particle. Ini jarang berlaku sebenarnya, tapi adalah. Okay. Effect of fault over current flow. When the fault occur, it create a very low impedance path for the current flow. This result is a very high current being drawn from the supply, causing tripping of relays, damaging insulation and component of the equipment. Danger to operating personnel. Fault occurrence can be also cause shock to individuals. Severity of the shock depend on the current and voltage, fault location, and even may lead to death. You tahulah fault is very dense. Sebab banyak kes you pernah baca paper tak? Orang yang kerja TMB contohnya, contohlah yang working with the power system utility. Mungkin nasib dia tak baik dia tengah repair whatever ada short. Dia boleh make the danger lah kat situ. May lead to the ni lah isu-isu macam tu lah meninggal because when you deal with the fault ni, you need to be careful. Banyak kes dia tengoklah kan dekat internet, orang nak naik dekat dia punya tower nak betulkan, tiba-tiba ada fault. Walaupun dia dah cut pun mungkin ada short mana-mana. Alright. Loss of equipment, heavy current due to short circuit. Fault result in the component being burnt completely, which lead to the improper working of equipment or device. Sometimes heavy fire cause complete burn out of the equipment. Saya kena besarkan sikit skrin ni, takut some of you tak nampak. Okay. Electrical failure, electrical fires. Short circuit cause flashover. Tadilah flashover. Spark due to ionization of air between two conducting paths, which further lead to fire as we observe in use such as building and shopping complex. So dia boleh make the, orang kata boleh terbakar rumah ke, ataupun yalah yang ada flashover tadi. Okay. Ini pun banyak ni. Ada bergambar kat sini. Okay. Ini semua flashover ni. Dan short circuit dia boleh keluarkan fire kat sini. Ini pun biasa terjadi. Of course dia ada protection sebenarnya. Dia tak adalah terus terbakar. Tapi because sometimes protection may, orang kata, fail to operate. So dia akan damage lah. Right. Sebab tu dalam area-area distribution kan, PPU ke, PMU ke, jangan dekat takut ada flashover. Kawasan tu boleh terbakar. That's why they always dia ada, orang kata, sign kan, amaran, caution sign kan, jangan dekat takut-takut berlaku benda-benda macam ni. Memang kita nak nampak tapi sometimes it may happen. Right. Importance of fault analysis to determine the size of protective device such as circuit breakers needed for installation, proper relay setting and coordination of protective device. So this is important of fault analysis. Macam kata tadi lah, size of protective device, you nak pakai apa? Circuit breaker. Berapa rating circuit breaker kita nak tahulah. Okay. Kalau you belajar tentang power utilization, you akan belajar lah ni macam mana you nak setting protective device. Macam mana you nak relay you. Based on the, orang kata, design current. You kira lah berapa. Tak apalah, you tak belajar ni. Just you need to know that to determine the size of protective device. Proper relay setting and coordination of protective device. To determine the capability of insulating material such as high voltage bushing in sustaining breakdown as a preparation for breakdown in power system. Kalau nak buat. Okay, fault analysis. Generally, there are two type of fault analysis. Yang sama, symmetrical or balanced faults, unsymmetrical or unbalanced faults. Kalau symmetrical, tahulah three phase fault. Okay, under symmetrical fault analysis, there are analysis with no load assumption where pre-fault voltage 1 per unit. Pre-fault voltage ni maksud sebelum. Kita consider sebagai 1 per unit. Yeah. Alright, analysis by considering load. Pre-fault voltage must be calculated. Analysis by using impedance matrix for large power system. Basically, kita guna assumption, no load assumption. Yeah. For the purpose of the chapter, only the analysis with no load assumption is covered. Because symmetrical fault is balanced, it is solved on per phase basis using Thevenin method. You all pernah belajar Thevenin method? Bila you belajar Thevenin method? Pernah belajar tak Thevenin method? Circuit analysis pernah belajar kan?
Pernah sir.
Current divider, semua itu tahu kan? Itu yang akan guna later on untuk fault analysis. Okay. Thevenin theorem state that the change in the network voltage caused by the added branch, the fault impedance, is equivalent to those caused by added voltage V Thevenin with all other sources short circuited. Yeah. Okay, so inilah dia. Yeah. I fault short circuit current 1 for Z. You kena tahu kalau dalam Thevenin method you kena tahu Z equivalent. You kena simplify circuit. Walaupun the circuit tu complex, you need to make it only one straight line, single line, in order to determine the Z equivalent. So ini equation calculator you can inilah dia Z Thevenin, Z fault. Kemudian lah kita akan buat exercise. The following assumptions are usually made in fault analysis in three-phase transmission lines. All sources are balanced and equal in magnitude and phase. Source represented by Thevenin voltage prior to the fault at the fault point. Large system may be represented by an infinite bus bar. Transformers are on nominal type position. Resistance are negligible compared to the reactance. Transmission line are some fully transposed and all three phases have the same Z. Load current are negligible compared to fault currents. Line charging current can be completely neglected. So this is assumption. Kalau baca buah benda semua ni tak apa. That's the assumption yang guna faham. Okay, symmetrical fault. Okay, dia ada example. Mungkin kita buat later lah kelas untuk next section buat yang ni. Tapi ini I stop kat sini lah, tak perlulah ni. Ini kalau I baca pun, I explain pun, you tak buat exercise, you tak faham. Okay, alright. You faham power system 1 ni dia banyak calculation kan. You tengok pada chapter 1 banyak formula yang you nak guna. You kena betul-betul faham barulah you. It's not only you nak jawab at test or exam, bukan macam tu Belajar memang gitu kan. Masa nak belajar ni, I pernah tanya student mana my student sini. Mana dia? Sini ke? Okay, kat sini. Alright. I pernah tanya student I pun student kat dulu sama macam you all juga kan. Faham masa nak exam or test saja. Lepas tu dah lupa. Betul? Bila habis exam, bila habis test, dah tak ingat dah apa yang belajar. Betul tak? Betul tak?
Betul.
Baik you mengaku.
Thevenin dah tak ingat sir.
Ya dah belajar tak ingat dah. Tapi kan you kena faham contoh 4 tahun you belajar kan. You akan fokus apa yang you buat semester tu lah kan untuk test. Yang lain dia lepas-lepas. You tak nak ingat dah. Tapi you tahu bila you nak, dia ada dua benda bila you akan pergi pada part 5, part 6, part 7, you akan guna benda yang you belajar sebelum ni untuk you advance to the next chapter lah. Kata untuk next topic course lain you kena ada basics. Macam sekarang lah, you belajar per unit kan. You pernah belajar, right? Jadi ceritanya, you dah ada idea kan. Walau orang kata, bila orang tu sebut sikit je, you dah ada idea. You have the idea, you have the basic. Itu yang penting. Sama macam you kerja kan. Mungkin you rasa sekarang ni tak guna, buat apa belajar ni susah kan. Whatever. Tapi, once you dah ada knowledge, you dah ada experience, you tahu pasal tu. Bila people talk about the things, you akan tahu, you akan faham. You cepat faham lah. Itu beza dia. Itulah dia. Kenapa you belajar banyak teori untuk bagi knowledge, untuk bagi idea kat you. Apa yang you nak. Because kalau you nak bagi idea, you kena banyak knowledge. Contohnya dalam power system lah. Kan? You kena tahu semua. Fault, you kena tahu tu, tahu ni kan. Jadi you ada idea kat situ. So belajar sebenarnya memanglah kalau ikutkan you nak buat, you nak dapatkan scroll degree, nak kerja kan. Tapi proses you nak sampai situ tu, kat situ lah you gain knowledge. You cari. Okay. Alright. Okay, I think kelas pun dah 9.30. I rasa cukup lah untuk hari ni. Ya. Yeah? Boleh guys cukup hari ni
Boleh, sir.
Boleh, sir.
Alright.
Boleh, sir.
Attendance pun okay, 26 daripada berapa orang tak datang. Kelas better you datang lah. You join kelas. Attendance memang I akan tengok. Semua I tengok lah. Okay, jangan rasa you boleh buat test 1, test 2, you dapat skor. No. Dia akan tengok juga pada attitude you. Lepas belajar ni, instead of you nak skor, bukan macam tu. Belajar ni you nak disiplin. Sama kalau you tak disiplin masa you dalam kelas, macam ni you nak kerja nanti. You tak ada disiplin. Kat sini lah you nak train yourself. Itu dia. Attitude you, macam mana you respect you punya partner, respect you punya lecturers, you nak it's not become a good engineer ni bukan setakat you excellent in academic, tak. Social personality you, itu kena jaga dalam tu. Okay. Tapi I tahu my students semua okay, semua good. Alhamdulillah. Okay. Alright, semua okay, semua sihat. Kita tahu COVID sekarang ni tengah meningkat. Kalau tengok graf tu kita kata bullish lah. Bullish ni dia mencacat naik kan. So stay safe. Jaga diri, jaga family you. Kan? Make sure you always betul Winston, sangat menakutkan. Kalau area Selangor, I duduk Selangor Puchong kan, so you tahulah, you tengok berita hari-hari kan, Selangor is the highest cases every day compared to other state. So yang mana ada Selangor, mana-mana pun sama, kita dah satu Malaysia dah, tak boleh nak kata apa dah. So make sure you always sanitize your hand, pakai face mask, bukan sebab kata sama 10,000 bukan sebab tu untuk jaga diri you. Sebenarnya COVID ni, you tahu COVID ni dia, kita start tahun bila COVID? Last year kan, 2020 kan. So when it start 2020, dia ada, kita kata first generation of COVID COVID-19. Itu COVID ni kita kata virus lah, you tahu virus kan. By 2021, virus tu dia dah mutate. You faham apa mutate apa? Dia mutate, dia dah berubah lah ikut. Dulu virus kata dari China kan. Itu China punya version. Sekarang ni virus tu dah mutate. Mutate maksudnya dia ikut region, ikut area mana virus tu ada. Sekarang ni kita ada 3 virus mutate from the COVID-19 2020. Kita ada 3 type of mutate of the virus. Mutasi lah kita kata. Dia ada satu pada. Dia dari mana? Daripada African kan. Virus version African. UK, India. Yang bahaya sebenarnya dah ada 3 sekarang ni. Yang orang takut African, India kan. India tu kalau ikutkan satu hari 5,000 orang mati, 6,000 orang mati, 200,000 positive per day. You bayangkan berapa juta orang kena kat India. Satu lagi virus Brazil mutasi from Brazil, COVID-19 So 3 virus ni sangat bahaya sebab dia bukan COVID 2020, dia new mutation of the virus 2020. So belum ada vaksin. Vaksin yang you guna sekarang ni, kalau ada pun yang dia orang duk bagi pada rakyat sekarang ni, vaksin untuk virus first generation lah kita kata. Untuk second generation daripada Brazil, India, Afrika belum ada lagi virus. Betul kita kata vaksin sangat bahaya. Dia kata kebal daripada vaksin. Setengah COVID ni dia yang varian baru, new variant ni, kita tak boleh detect. Kita tak tahu orang tu ada bila detect pun dah critical. So itu dangerous. So please make sure you jaga kesihatan. You janganlah pergi mana-mana tempat orang awam ke whatever. Stay home lah, better buat masa ni. Mungkin yang paling bahaya mungkin kalau you kena sebab you muda, you are strong. You punya orang kata antibody tu kuat betul You muda lagi kan. Tapi the problem is your father, your mother, your nenek, atuk, whatever kan. Sebab dia orang dah berusia. It's very dangerous for them. Because COVID ni dia akan serang pada pernafasan. Oksigen dia akan effect. Jadi kalau orang yang dah penyakit semua tu, dia sangat bahaya kan. Kita minta jauh lah tapi kena hati-hatilah Itu je I boleh pesan pada my student Okay. Okay guys semua, boleh
Boleh sir.
Okay.
InsyaAllah sir.
That's all. Thank you very much. See you next class. And Assalamualaikum dan salam sejahtera Okay, bye-bye.